Continuing on how to solve this graphically, look at this question. This is the question we did earlier algebraically on the first podcast in this section. But what I want to show you is how the heck do you do something like this on your calculator? Well, simple. It's still equal to 0, right? So being that it's equal to 0, guess what you're trying to find? You're trying to find the zeros or the roots. Yep, you betcha. But how do you put secant into your calculator? Because if you look on your calculator, there is no secant button. There is only sine, cosine, and tangent. Well, you got to be smart. That's all. You have to remember something very, very important. You have to remember that secant is in fact 1 over cosine. Aha. So rewrite this right now. Go 3, right? You can put it as 1 over cos x, right, minus 5 equals to 0. Now, if you're smart and you're really cute at doing this and you're comfortable with fractions, you know that's over 1. So this, in fact, is 3 cos x minus 5 equals to 0. That's the y1 equation that you're going to put into your calculator now, and just find where that intersects and give me the answer. Okay, so let's do this. Putting it into your calculator now is actually a piece of cake. Here we go. Bada-bum. Go to your y equals 2. Immediately put it in as a fraction. Bada-bum. Remember, it was 3 over cos x. There it is. That's the beauty of that fraction button. And then, don't forget, this is subtract 5. Right? There's your y1. There's your equation. All pretty. Hit the graph. What the heck? What is that? Okay. Well, most importantly here, though, here's the thing. You're still in radians. Look at your question. Your question asks you, degrees. So we got to go back now. We got caught the first time doing this. We're going to get caught again and again unless we clean this up. Okay? So let's go out and let's change this guy now to mode. Okay? Down here, 2 degrees. Boom. If we graph this, we're going to get something that looks like this. Still completely wrong. The reason why is because remember, your graph here should go from 1, minus 1, there's your max and min, but all the way up to 360 degrees. If you had it set up for radians, you're going up to 2 pi. So this becomes a little bit of an effort of changing your window settings again. Yeah, so what? Minimum is 0. Change that to 360 degrees. Look how everything else is going up perfectly. Maybe your scales, change them to, let's say, 30-degree scales. Let's do that. Your Y min and Y max look perfect to me. Punch it. Punch it. Let's see what it looks like. Boom. You still get something that looks awfully weird, don't you? This looks really, really strange, doesn't it? Yeah, it does. So one of the things you have to remember is that 1 over cosine could in fact have a 0 in it, right? If you're doing 1 over cos, think about this. 1 over 0 means, yep, you got it. You're going to have a non-permissible value. That's why these guys come up like this. There's actually where your non-permissible value is. Right over here is, again, another non-permissible value. Oh, lovely. Well, you don't have to worry about that right now because all you're interested in is what are these zeros here and here. That's it. So let's figure out what those zeros are. Second calc, find me the 0, 2. I can't see anything. I got to clean this up. I can't read that. Oh, there we go. Okay, left bound. Notice where you're at. You're at 180 right now. You're way out of here. Let's get closer to where our angle is and where our intersection is. And if I keep hitting this, I want you to see something really, really cool. The X hasn't shown up yet. There it is, finally. There's our X. So keep mousing until that X shows up. Left bound, there it is. Right bound, there it is. Guess, you got it. And you got 53 degrees, just like we found out in the first podcast. So your first answer is 53 degrees. There's no changing, no chasing around and dividing out by pi or anything like that. 53 degrees is 53 degrees. Punch it, okay? Find me the next one. Here we go. Second calc. Find me that 0. Now, we got to go all the way out here, which is close to 360 degrees, because remember, that's how we set up our window. So we're right now at 51 degrees. We're not even close to it. Okay, let's go. Punch it. We're getting closer. Look at those numbers change on the bottom there. Look at those numbers change. Still not close enough. Still not close enough. Here it comes. I bet you it's going to be here any second now. Then there it is. Oh, I passed it. There it is. Enter and right bound. Enter. Guess. And I got 306 degrees, 307 degrees as before. So 307 degrees. Now, how do we draw this thing so it looks actually like we did this graphically? Well, okay, 53 degrees. Where is that? Oh, 1, 2, 3, 4, 5, 6. Oh my goodness, 53 degrees. Looks like, well, if you think of the middle, 1, 2, 3, there's the middle. That's going to be 45. So probably somewhere around there is 53 degrees. Okay, where's 307? Well, there's 360. So 360 is out here, right about there. 307, let's just make it a little bit less. Let's put it, I don't know, right around there sounds good. Go back to the graph. Remember, these are just sketches, okay? So this looks like it's going up at this section here. So we're going to put this guy going up like that, okay? And on this side, it looks like it's going down. Okay, so on this side, it's going to be going down through there. Label these points here and here as your 53 degrees and as your 307 degrees. And my goodness gracious, that was fun and easy. But what's bugging me right now is I told you that there's asymptotes in there, but I really didn't put the asymptotes down. Why don't we make this graph a little bit more accurate by putting those asymptotes down? Think about it. Look at the quadrantial angles. Remember, we're dealing with cos, and cos cannot equal to, so you can even put it down as a restriction, cannot equal to 0, which means where is cos 0? Cos is not 0 here, cos is 0 here, and cos is 0 here. Cos is 0 at 90 degrees, and cos is 0 here at 270 degrees. Aha! So there's your non-permissible values here and here. So let's just add that to the graph just to be really smart. There's our non-permissible value. There's our asymptote at 90 degrees. 270 degrees is going to be out here somewhere. Okay, boom. There's my 270 degrees. I don't know if I'm accurate there, but I'm just kind of sketching it. So that's why I'm labeling it. There's our asymptotes, making this graph have a lot more clout, as we should say, because we actually even put in the asymptotes. Pretty cool, huh?